Hello everyone, welcome all on Data Phoenix webinar. Today with us Denis Linkov. He is ML lead at Voiceflow, and today we will talk about RAG solution and what lessons he learned from building these RAG solutions in the Voiceflow. So I give to him microphone.
Thanks, Dimitri. Hi, everybody. I'm Dennis. I'm the machine learning lead at Voiceflow. I've been with the company for 2.5 years now, and we are a conversational AI company focused on AI agents. We were in this business before ChatGPT, and like many companies, had to figure out how to navigate sort of the change in capability and also user expectations for conversational assistants. So for today, I'll be talking a little bit about what we've learned in implementing our managed RAG solution, which we call our knowledge base, and just walk you through some of the challenges and learnings we've had along the way. And I'm based out of Toronto. I know Shahir just said hello from Bangalore. Hello to everybody joining the call. So let's get started. We're going to talk about just a general agenda, walking through some of the history of information retrieval, talking about the product we built, how the initial architecture was designed, sort of how users use the product, go through some things on hallucinations and testing, and then talk about some costs and limitations that we've experienced. So what was interesting was that when ChatGPT came out, this whole idea of chatting with a document became very, very popular. You've probably seen Chat with PDF, or I don't know how many dozens of projects there are out there. It's become a pretty popular intro to LLMs project too. So there was a desire in the market to summarize and discuss content and focus on these information retrieval tasks. Now, what's interesting is that even though it gained a lot of prominence in 2023, information retrieval generation has been around for a while. Here's a summary paper, I think, from 2022, talking about all the different responses here and capabilities. You can see here there are many models, and in the bottom, you can see that there's GPT-3 in there. So there are actually a lot of interesting other approaches to doing question and answering and generation that exist, and many data sets that worked on this as well. So, and if you actually look at the ranking for GPT-3 here, it didn't score at the top of sort of accuracy metrics for most of them, right? So you have these different data sets, trade-offs between speed and memory and all of that fun stuff. But GPT-3 at the time was not the best model to work with. Even though the other approaches were supervised, still some challenges. Now, when all this information retrieval was going on, we needed benchmarks to do this. So one of the popular benchmarks is called beer, which is part of that joke of having a drink, right? So the beer benchmark is a multifaceted, multi-domain set of tasks that are available to do summarization and retrieval tasks. They focus on different domains. There's things like news, medical data, financial data, and so forth. And it's a good way to assess how well your system actually works across these different tasks. Now, this obviously has some changes since ChatGPT and GPT-4 and other models have come out, but it's a good starting point when looking at sort of managed RAG solutions and information retrieval. Now, one of the interesting things here is that chatting with a PDF, you can actually have a use case where you might want to have a certain persona or a certain way of structuring the data here. So I'm going to show you a quick video and walk through. Quickly. So what I did here, this is in Voiceflow. We have added some documentation on Git from Atlassian's website. And what we have done is that we've actually, rather than just chatting with this document, we've built out this flow to do so. We've added the ability to have a persona here, which is like speak like Darth Vader. So this is kind of funny. You get into the ability to actually augment responses and tones and everything else. So we can be like, tell me about Git. And we'll get a response here based on the documentation, but it should be structured like the Darth Vader persona, right? Talk about young Padawans, all that fun stuff. We can ask, how do I rebase? And once again, we should get our concrete response, but because we've done some prompt engineering here, it should be based on, the Darth Vader side of things. So we start getting into these use cases or these desires of actually customizing what the response are and building out something a little bit more complex. So what was interesting is that we were starting to see these different implementations of ChatGPT, chatting with a PDF, and we wanted to say, how does this actually integrate with our platform? So we did a POC. This is actually more than 7 months ago. I didn't update the slide. This was closer, what is October, 10 months ago now. So to figure out what can we actually do with this kind of RAG solution. So what we did is we built a little prototype, which is doing some testing with Q&A on Voiceflow. And this was like a very first version. We uploaded some documents from Zendesk and our own tickets and wanted to make sure how it works. Now, what ended up happening is this was like a very basic one running not based on our core infrastructure because it was a proof of concept to start. And the architecture kind of looked like this. We deployed a separate instance of infrastructure. We connected it to our blog post. We used OpenAI and Pinecone. Then we used the API functionality from Voiceflow to actually connect to it. And you could ask questions to it based on our documentation, get some URLs and other things like that. Now, this architecture was great for demos and to conceptualize what this might look like in the product. But eventually we decided that this was not enough. We should actually productize it because this was, it was a proof of concept and not ready for production. Now, the way the core ideas behind it were sort of taking a step back is that we needed to build a retrieval system to get the relevant information. That's kind of the important part about RAG, right? It's the Retrieval Augmented Generation. And we needed to use embeddings to do so. So pretty important foundation here. Not sure about everybody's background in RAG systems or semantic search, but basically each document we would parse into a machine readable format. And we would do that with ML models that created things called embeddings. And then for any question that you would ask, you would then compare the embedding of the question to the embedding of the document. And then you'd get some results back. And what's interesting is that when you're trying to choose which embedding model to use, let me zoom in here. There's obviously trade-offs there. So this is a benchmark that Hugging Face maintains on various data sets, including beer, as we mentioned, on a variety of different embedding tasks. So you have things like re-ranking, retrieval, clustering, all these important things that we typically use embeddings for. And this actually changes quite often. I made sure to pull this from yesterday because there were some new models there. But interestingly enough, OpenAI does not rank even in the top 10 based on this benchmark. Now, the challenge for us actually is that we support multilingual use, and most of these models, apart from multilingual E5 large, the open source models are not multilingual, right? So BGE and GTE have English and Chinese versions. The other models aren't great at other languages. So as a product decision, you have to choose a model, either choose multiple models across languages or you have a single embedding model that works across many of them. So kind of interesting, as these models continue to get updated, these decisions will change. But from an embedding and retrieval perspective, you need to make these trade-offs of sometimes the best model to use isn't actually the best model for your use case. And sort of as the space has developed since we've done that POC almost 10 months ago, there's been more and more architectures and blog posts and everything else written. Here's one that a venture capital firm wrote about, and they sort of highlight some of the important portions here. In practice, some of these architectures are more complex than they need to be, but they try to capture some of the important aspects of it. So when building a V0, right, for example, we didn't implement caching because it was quite complex. A lot of the logging and LLM ops and validation was quite basic, right? We just wanted to make sure that it worked for 95% of use cases, and then we would build what comes up. But likewise, as you're sort of building out these solutions, you have to be very specific in what you want to achieve. Otherwise, it's very easy to get lost in all of the hype that's surrounding this industry right now. So with the product that we built the knowledge base, as you saw in my demo. You upload some documents, it parses them, and you have various options to figure out what's actually in there. So the first thing that we shipped was the ability to actually see what's in your knowledge base, ask a question, as some transparency to see as a user what is going on. Now, there's obviously more that we can do with the transparency side. For example, showing the exact prompts that you're using, showing the chunks beyond just the sources. But we made a decision just to build sort of a first version. And our initial hypothesis was that we wanted to use the knowledge base whenever, if somebody's using a static chatbot, the chatbot can't respond, search the knowledge base to do that. Now, what ended up happening is us realizing that we should actually have a knowledge base step, right? So rather than just having this fallback, we should actually let users search the knowledge base in a more progressive way. So that hypothesis actually was right, that people were using it, but was not correct as the main way to actually use it. And to the question from the audience, yes, I'll make these slides available. So the core question is, if a user is talking about a specific set of items or specific questions we want to answer based on this knowledge base, we should allow them to do that. This kind of gets into the hybrid architecture of using traditional NLU models for classifying user intent versus using a knowledge base. So the hypothesis became that we should allow users to do both. And to validate that, we've actually built many of our own assistants. Our Voiceflow assistant on the website and on our Discord and many other places does this, where it's a hybrid. So to be a little bit more concrete about it, let's build a quick project with Voiceflow here. So I'm going to make a new assistant, select the AI assistant type, call it Tbot. Okay, I have one already. Let's call it Tbot new. And one of the things that we do is that we show users a disclaimer depending on what tier they're on. So I know guardrails, risk, all those things are things that people care about. So we want to be specific about it. Because I'm on an enterprise plan internally, there's a more explicit pop-up as opposed to free users. So I'm going to build for web chat. We have different options here. Select English and go forward with that. So I get some starting templates here. I'm an experienced user, so I can delete them. But the core thing that we're going to do is we're going to import something into our knowledge base. I have this document.t. So let's go ahead and add this data source. And then as this is being automatically parsed, we'll be able to ask those preview questions. So almost done here. I can go to preview and say what types T are there, and you'll get a response, right? And we have our sources here that are based on the chunks. So in this case, Wikipedia is a very nicely structured data set. If we're familiar with trying to parse data sets, we've tried to parse other data sources. The chunks come out quite well. For other data sources, like if you have non-structured PDFs or like text blobs or even certain websites, it can be a little bit messy. But surprisingly, large language models do a pretty good job of actually summarizing it. Now, the other hypothesis we had is that users want to use different models. So in this case, this is Claude Instant. We have other models here, ChatGPT, GPT-4, Claude 2, etc. And you can customize some of the functionality that you're working on in terms of which chunks that you're using. Don't know why that's not loading. There we go. How many chunks you're using, what your system prompt in is, your temperature, max tokens, etc. Now, if we wanted to add this to the canvas, we can do that. So let's add a text step. We greet the user, say something like, hey, do you want to learn about T? Can I help you with? And then we can capture what the user responds with. Under listen, go to capture. And then respond either with static text or with an AI response step. Let's do the AI response step because that's more fun. And we're going to connect it to our knowledge base here and have the last utterance, which is what the user is saying. Now we've created our T-bot. We can go ahead and run it. What kinds of T are there? And we'll get a response here. So this is great for prototyping. You can collaborate with your team about it. So we kind of integrated it with the product as a natural extension. Now, the other nice thing is that we can go ahead and publish this. As that's publishing, we can actually add it to our website. I'm going to do a nice JavaScript trick in here where I'm going to put it on Wikipedia. So copy the snippet. If you're familiar with front-end development, you can just put it on your own website. Go to inspect, go to console here, and we'll have a T-bot here. We can customize this as well, right? We can change the colors, change the actual language, right? As we see here. We have a bot in production in a couple of minutes. Hey, when was T invented? Oh. And we'll get a response for that. There we go. So we built an assistant. It makes sense how to build an introductory one, but as people are building more advanced ones, right, we want to make sure that it matches their use case as well. So let's dive deeper into what more advanced use cases look like. So the challenge that we had is when you see a text box that just says add a prompt here, users try to do a bunch of funky things. Some users who are more advanced want to do more advanced prompt engineering, prompt refinement, using variables, templates, all that fun stuff, which you can do. Other users assume it's just like ChatGPT, where you can provide it instructions or actually have a natural language way to query the knowledge base. So when somebody says something like this, search customer A's data about question, this is an interesting thing because from a UX perspective, it makes sense, right? If it's a knowledge base, you give it instructions what to look at. But from a technical perspective, you now have to discern what customer A is, right? You can add tags to it with things like unread. But from a managed RAG solution provider, we now have to make the decision, are we actually going to try to parse these tags? are we going to try to extract these entities within our own prompt, right? So that leads to trickier things from a UX perspective, because users are expecting this magical AI response, but in practice, you can't actually do that. You can put a prompt, you can put a prompt template, but you can't specify what in the knowledge base you're looking for unless you've explicitly tagged it. So that makes it much trickier, right? People might want to basically write things that are similar to SQL as well. We've seen this with user examples, but our product doesn't support that. So it's something that we've been trying to refine, is how do you actually communicate this through the UX and not have users get frustrated? Because in code, it's much more explicit, and usually you have users more familiar with the domain, as opposed to our platform where we also get low code, no code users. So we've avoided this for now. In natural language, we do have a tagging feature where you can query and filter based on certain things, but natural language sort of database searches are its own can of worms. So there is a question about the knowledge base and API calls for every single response. So this is a great question and something that we've been trying to figure out. So I talked about not implementing caching initially. So we run into two main types of problems. The first one is LLMs are non-deterministic. So if you cache a response, you need to have some kind of certainty that it's right. So this is where kind of a generated initially and then cache it as an FAQ kind of comes up. So we do have a beta program running on that to see how people use it and the performance. The second thing that gets trickier is that we allow memory to be used. And now it comes up with a question of that if a user says something beforehand in the memory portion, likely the longer the response, the lower the probability that the response will be exactly the same as a lookup. So you need to have some kind of way either to evaluate if the nature of the question is the same, or the nature of the conversation is the same, or it's different. So you get into these trade-offs of how many tokens or resources are you actually spending evaluating the prompt or the conversation versus actually caching it and saving it. So those are the two main challenges that we've run into. And I think it's still a challenge in the industry. Like, how do you do non-deterministic caching as a whole? So great question. Short answer is that we're working on this, but there's no straightforward bulletproof solution. There's always trade-offs. So about LLMs, you saw in Voiceflow you can choose various LLMs to do so. And the challenge is that when you start doing RAG or any kind of prompt engineering with context, LLMs get very expensive, right? So if you're using 2,000 tokens, which is roughly on the upper end of what a knowledge-based query looks like, or a fairly large prompt, every query gets quite expensive, right? 12 cents for a larger context GPT-4 model, fractions of a cent with ChatGPT or Claude Instant. So I have to be cautious about that, which is why within Voiceflow, we try to help users pick what the right model is. On top of that, you have latency challenges. So we were originally using OpenAI's version as our provider. Then we switched over to Azure to reduce some of the latency and standard deviation. This was a decision we made earlier in the year. But what's interesting is that the latencies actually vary across the models. So Cloud Instant actually had the best or lowest latency for small queries, as opposed to even like ChatGPT or Claude. But what's interesting is that initially we faced a lot of issues with variance and high latency. And this is a third party, Helicone, which did some benchmarking back in April as GPT-4 came out and ChatGPT got more stable as an API. But more recently, more services have been seeing that latency has fallen here. So you can see here, ChatGPT 3.5 and GPT-4 are much faster now on the latency, which makes it interesting because now you start running into throughput challenges, right? If I can do so many calls to the API and it's returning much more quickly, I run into challenges with actually token quotas and such. And here GPT-4 has fallen in terms of latency as well, which is great. Now the challenge is that P99s, so the requests that are in the top 1% of latency or the 99th percentile in slowness, they still have significant latency. So the median here, if we look at September 1st, is closer to 1 millisecond per token, but for September 1st on P99s, it's much closer to 20 or 60, depending on the model. So that's where user experience gets tricky because sometimes the response is fast, sometimes it's very slow. And it all depends as well on sort of what kind of instance you're running it at, what time of day it is, et cetera, et cetera. So some of the risks of using a third-party provider, but at this point, it's still the easiest thing for us to integrate with because these APIs are easy to use, and especially ChatGPT is quite economical as well as compared to other models. Now, when we were doing testing, we set the default to use Claude Instant based on cost, because we do pass some costs on to the user, but also latency. So we didn't want users spending too much time at the beginning configuring their model. We wanted them to be comfortable just having a default. And when they're more advanced users, they can actually pick this. So typically, if you're building your own RAG solution, you're using LangChain, semantic kernel, any other platform, you would have to set all this up yourself typically. So our goal was to limit the choice you had to get started, because otherwise there's so many knobs and dials to turn. Now, going on to cost, as I mentioned, we do pass on some of the cost to users. And one of the actual challenges is that you have different costs depending on which model that you use. And this can be challenging for users to actually understand unless they're diving deep into this. So we decided to say, okay, we have all these different models that exist. How do we simplify this? So we abstracted it with a concept of Voiceflow tokens. So we have the idea of tokens, and there's different tokenizers based on the OpenAI models or the Anthropic models. So we've calculated a rough multiplier so that you can see what the relative cost is. And you just buy in sort of this base token case where you're buying Voiceflow tokens, you're charged by Voiceflow tokens, and you can see transparently how much each query is costing you. So for example, if a knowledge base answer requires 1,000 base tokens, and you're using Claude 2, based on that 10x multiplier, you'll be billed for 10,000 tokens. And this allows users some more transparency to see, if I'm using GPT-4, why am I eating so many tokens? The reason is because we want to standardize pricing, and we've chosen this token method to do. So there's a question in the chat. What if you want to use an instruction fine-tuned model from Hugging Face or one that you've fine-tuned already? That's a great question. You can do that with the API step to do so. And for some of our enterprise customers, we are helping them connect via their own LLMs. So this is, again, a challenge because Voiceflow has 130,000 users, most of which are free. Building out explicit integrations takes a lot more time, and we need to be more thoughtful about it. We have all the building blocks already, like an API step to call out to Hugging Face and various tutorials on how to do that. For the bigger customers, which have more specific use cases, we built out more specific integrations. Hopefully that answers your question. There are demos on there, like how to do even like text to voice with Hugging Face models, specific classifiers that you can use, LLMs, etc. We just provide this stuff out of the box, which is simpler, but allow you to do more custom stuff too. And part of that pricing is that we want to give users a way to actually build something that's cool and powerful. And this is kind of how our pricing structure is right now. You get 100,000 Voiceflow tokens on the starter plan. You upgrade to Pro, you get 200,000, and then Enterprise, you get close to unlimited, but that's determined at a contract basis with each of our customers. So the idea is that everybody wants to use tokens to build something, but we need to figure out how that cost plays for us in terms of how many free tokens we give to people. So something a little bit from an economics perspective that's interesting. Follow-up question on multimodal use cases. Yes, it's a great one. There are some demos out there with using Voiceflow for that. The OpenAI GPT-4 Vision API hasn't been publicly announced yet, right? So they have their developer conference where likely something will be announced. So no direct integration as of now. But again, Hugging Face models, you got the API step, you can go crazy with them. Now, the other thing that's interesting is that how do you actually track per assistant how many tokens you're using? So in the UI, there's a little box that says, for this project, I'm using this many tokens. But we had a bunch of questions of if I'm, for example, an agency or a big customer that has many assistants, how do I track this? So we shipped a more comprehensive API offering where you can query based on time, see your token usage, see the breakdown by model. In this case, this is our own assistant. We use a lot of GPT-4, and GPT-4 is expensive and uses a lot of tokens. So we're able ourselves to assess like where we're spending time, how much optimization we need to do, and likewise for customers. Because if you're building an assistant to solve a case to try to make customer support cheaper, right? You don't want to be spending more on GPT-4 than you would on other things, right? So a lot of interesting things. The second last section I wanted to talk about was hallucinations. So we hear a lot about this within any kind of LLM context. I wanted to provide some concrete examples, things that our users have run into and we've run into ourselves. So I put them into two categories, false positives and false negatives. So false negatives, sometimes you get a non-answer because in our prompt and in our tuning, we try to make sure that false negatives are better than false positives, kind of starting to answer the question in the chat. We get other responses like cannot find information in the context, even though it might exist, but it might be obscure. Sometimes if you've used LLMs, you have things like, as an AI, I cannot do this, right? Depending what model you use and what you ask. And then the final one is kind of interesting, is that when you ask LLMs to role play, for example, you try to override existing information, like we had some users writing stories on Voiceflow. So if Kansas, you might say it's 2025 or 2035, Kansas is now the capital of the world. In this future, like X, Y, and Z happens. And some models are like, no, that is not correct. So I'm not going to go along with this story. That's on the false negative side. Those can be frustrating to users because it doesn't answer questions, but generally are better than false positives. On the false positive side, generally the information has been correct unless the user question is quite complicated. Usually we found that misinformation, when you have a clean knowledge base, right, you've uploaded all the documents that you want, is quite good. But here are some issues that we found. Just based on how these models work, sometimes when you ingest data, you don't put the information that you want necessarily in the doc. So for example, when you have serial numbers or links that are in the documents, sometimes they aren't summarized correctly because the way that the model tokenization works, it truncates it or hallucinates some kind of subdomain or subpage. Or sometimes users just forget to put it in the doc, and it becomes kind of a UX question of how do you remind users, like, it won't be able to retrieve that link unless it's in the document, because then it doesn't get chunked. We also have this challenge where if somebody is using a different language and doesn't specify it in the prompt is usually in English. If they don't change it, a user might be having a conversation and it might swap languages. And it becomes more of a challenge, especially with something like memory, where you have a longer context and a higher risk for hallucination. To finish answering that question about Q&A bots for customer support, Yeah, it's a great use case. We have some use cases where companies have launched this to pretty good success. I think it's just being mindful of what questions are important. For example, some questions you might want to answer with a static flow. For example, if a user is doing an action that is highly destructive, like one use case we've seen is somebody says like we want to delete our account, right, using that chatbot. In that case, it's probably better to have a manual flow with specific language and a trained classifier on that to increase the probability of success rather than an LLM or something else. And that's because we don't want a user to take a destructive action. That misclassifies. So that's like a really bad false positive. For FAQs, like some things are like they're not the worst if they're wrong, right? Like we sometimes deal with this in our Discord bot. So if you've been in the Voiceflow Discord, we have our chatbot Tico that tries to answer user questions. And sometimes it just answers the wrong question, or a user is looking for something that's more advanced. So that's like a continued area of research for us, is that how do we actually segment based on past conversation history and all these other things from a user? How do we provide them with the right answer? So there's like the base case of this answer is flat out wrong, but sometimes based on the information we have or previously asked questions, it's not the right answer for the right user. Hopefully that answers that. Now, to deal with the hallucinations, we've been building our own LLM testing framework. We've been using it internally for several months now, just to evaluate prompts, figure out what use cases make sense. And we're in the process of productizing that because a lot of our users are like, hey, how do we how do we make sure my FAQs are answered correctly, or my chatbot isn't hallucinating, or how do I actually know how good it is? How do I choose a model? So all these things are something that we've been building and refining and figuring out the right user experience to productize it. And you get outputs, right? In this case, it's a fancy dark green output, just being like, okay, these are the prompts, this is the response, this is how a model behaves, and all this other metadata that we use. Now, the final part I want to talk about is some challenges with vector DBs. These are kind of the 5 main challenges we ran into. So for our public cloud offering, each user has a logical separation based on namespaces or other such concepts, similar to any kind of shared database. So how do you actually do proper multi-tenancy is a challenge. And then as you have more and more users joining, how do you scale properly? Each VectorDB provider has a different strategy, whether it's by scaling up the machine, creating another index. Some have auto clustering as well. That's been something that we've been trying to be thoughtful about, is how do we do this properly so it's a scalable solution. Also have the challenge of sometimes reconciling data, like people go in, delete documents, halfway through change their mind, try to rename a document, all this fun stuff with data management. And the final one is indexing. Every vector DB works slightly differently on indexes, whether they're composite or as metadata or general hierarchy, like the hierarchical clustering that they typically do. So yeah, there's certainly nuances. To give everybody a specific example, for multi-tenancy between two large vector DBs. So with Pinecone, the recommendation is to use something like namespaces. So you search based on a namespace, and that's how users how you do multi-tenancy. They also have other options. If you look through their docs, you can use tagging and filtering, or you can create a separate index. Now, this concept of a namespace doesn't work as well in Quadrant. Their recommendation is to use tagging and filtering as a different layer of abstraction. And when we were testing these two things out, right, we ran into this issue where concepts across multiple vector DBs don't map one-to-one. So something that we had to figure out along the way. Yeah, so that's the end of the talk. Happy to answer questions. I know another one just came in, but thanks for joining, and let's go through some Q&A.
Yeah, thank you for this interesting presentation and share your challenges and how you solve it. And yeah, so we have some questions more. And I also have one question. Do I understand correctly that, or not, is it possible to use your platform as some backend for my own business logic? If I don't want to build my RAG solution, can I use you as build some logic in your interface and then connect it as API to my system?
Yeah, for sure. We do have a fairly comprehensive set of APIs. So different users, some users want to build in the canvas, hit a button, auto publish. Other users want to connect via an API. We've seen a combination of both.
Mm-hmm.
Yeah.
Yeah.
Um, Joseph had a question. How many languages does your vector database handle? Can I have multiple language where I ask in my native language and it searches foreign languages and responds in my native language? So this is something that is more of an edge case that we found. Typically, users upload docs across one language. We found that it depends on the embedding model. So OpenAI does a decent job doing cross-lingual search. Other models do a good job too. For example, paraphrase model set, the E5 model set. But other models, there's similarity across they're similar within a language, but not across languages. So it depends what embedding model you use. And it's also tricky because when you provide the prompt, every model deals with languages differently. So ChatGPT and GPT-4 are quite multilingual. We've had challenges with Claude for some languages, like there's just no training data on it. So Claude instance and Claude does not do the best job on it. So depending on the use case, it could be good or bad. And then you have the whole question of domains and such as well. So
Yeah, we have more one question about how you deal with non-deterministic OpenAI response after testing dialog flow.
um, I'm not sure I fully understand the question. Could you give another example? So when we deal with those responses, they usually go straight to the user if you're using it as a direct response. If you need to, sometimes you use an LLM to do classification tasks. So for example, classify is the user happy or sad, all this other stuff. So that's where the prompt refinement goes in. And sometimes the non-determinism is too much. So you'd prefer a static flow, buttons, or training an NLU classifier, which has specific examples of how do you want to handle what the user says. Because yeah, sometimes the user puts something random and it completely breaks the LLM and they say something very strange. So that's, as a platform, our goal is to give users the capability to do so. And at the same time, we have to test it enough ourselves to have confidence in what we're building. So.
Yeah. Okay, I think we're good for all questions. Say again, thank you for uh, your time and for your presentation. Thank for all who was with us. Oh, we have more one question in the last minute. Do you use any prompt management system? It's an interesting question.
Yeah, so internally in that testing suite, we do prompt management through that. Prompt management is an area that we're actively researching and prototyping on how to add, because yeah, if you have a complex bot, modifying prompts sort of in a single node is challenging. So completely understand the use case there.
Yeah, thank you. Good. Okay. So thank you for all who was with us. Thank you, Denise, for your participation and your presentation. If we will have more questions, let's continue discuss in our Slack channel. And see you next week. Thank you for all. Bye.